All right, let's look at the homework 12.3, problem number 10. All right, so we want to find the work done by a force, vector F, that moves an object from point 0, 8, 6 to 2, 12, 20. All right, so let's do that. All right, so you have a point, so I'm going to just put a point here. So this is has a coordinates 0, 8, 6. So this is going to move to another point. So it's going to go along a path, say something like that. And then it's going to move to the other point, which is 2, 12, 20. Right? So I'm going to view this as a vector here. Right? So I'm going to call this vector V. Right? And this is going to be, right, so 2 minus 0 is 2, and 12 minus 8 is 4, and 20 minus 6 is 14. Right, so that's the vector V, so like the path vector. Right, then force, it's probably not parallel to this, so you have a force acting on this object, so I'm going to have a force here. So capital F. So vector F is going to be, right, so it's given, so 8, negative 4, 9. Right? Since the force is not parallel to the path, we have to look at the component of this force. So we take the component by just coming down. Let's see, let's look at the component here. Right? So the component of it can be found by simply taking, let's say this is the angle theta, right? So the component of this is going to be simply take the magnitude of the force, then you have to multiply by cosine of theta, right? So that gives you this much there, here, right? So that will be actually the component of the force in the direction of the movement. All right, so all you have to do to find the work would be, so I'm going to call work W. It's going to be, so remember that the work is force times distance it traveled. So you have a force's magnitude of vector F cosine of theta multiplied by distance. So distance is the magnitude of V. Right? Then you notice that if you rearrange it, this is actually magnitude of F times magnitude of vector V cosine of theta. Right? And this looks very familiar because using the law of cosines for vectors, this is really the same thing as a vector F dot product with vector V. All right, so let's compute that. So this is going to be a vector 8, negative 4, 9, and dot product with 2, 4, 14. All right, so this is going to be, all right, 8 times 2 is 16, plus negative 4 times 4 is negative 16. All right, plus, all right, so we have to multiply 9 and 14. 9 times 4 is 36. And 9 times 1 is 9, so 126. Right, so you can cancel 16 and the negative 16. So the work we're looking for is 26, sorry. Right, so joules. Right, So let's type it in. All right, so 126 joules. Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.